at contamination, there are four major contaminants. That's microbial or microbiological. That includes bacteria, viruses, molds, yeasts and parasites. Chemical contamination, strong aftershaves, strong perfumes. Could be pesticides, herbicides, agricultural residues, too many preservatives. Physical really means items that you can see, and they're normally a bit of a nuisance factor rather than a food safety hazard. Albeit if there are things like sharp screws or sharp pieces of glass, that can obviously be a food safety hazard that can cause cuts and bruising and choking, etc. Allergenic includes things like nuts, soybeans, celery, sesame seeds, and anything really that causes an allergic reaction to food. Going back to physical contamination, that can occur from a variety of sources. That could come from the person who's working in the food preparation area, from visitors, could come from the building itself, from equipment, from supplies. For example, you might have external packaging that might have sharp screws or staples, bits of plastic, or could be rubber bands. In fact, physical contamination comes from a variety of sources, so beware with that one. And I suppose that could be an example of all the four contaminants. A mouse that has been cooked and sliced with a white loaf of bread. There possibly could be some microbiological contamination within the mouse itself. Chemical contamination, especially if the mouse has just eaten some pesticides before it ended up in the loaf of bread. It's definitely a physical contaminant, and you might well be allergic to eating a mouse in bread, so there'll be the allergenic part. So we've had a look at the contaminants. Now let's look at the definition of cross-contamination. Cross-contamination is the transfer of food poisoning bacteria from a source to a high-risk food. There are several different types of cross-contamination. There's direct contact cross-contamination, where raw food actually touches high-risk food, and there's indirect cross-contamination, where the bacteria get from the raw food via what we call a vehicle. That could be a knife, it could be a work surface, it could be a chopping board, it could be a cloth, etc. And then the bacteria end up from the vehicle onto the high-risk food. Let's have a look at the sources, vehicles and routes of contamination with the indirect cross-contamination. The sources could include human handlers, pests, domestic pets, vegetables with salt contamination, raw meat, in sanitary containers like the bin that's showed in the diagram there. So all these can contain or have the potential for containing pathogens. The vehicles could include cloths, knives, preparation boards, food containers, possibly hands. And that could take us then to the high-risk foods. The high protein foods that the bacteria will multiply on. And you've got some examples there. You've got cheeses, quiches, cooked meats, cooked poultry. You've got some shellfish there, eggs, mayonnaise, milk, ice cream. And the last example of cross-contamination is drip, which really is direct cross-contamination. That's when raw meat juices drip onto high-risk food. So it's very important when storing raw materials in the same fridges and chillers as high-risk foods. The raw food should always be on the bottom shelves, the high-risk food on the top. If you do it the other way around, then you will get the scenario that you're looking at the moment. Raw meat juices dripping onto high-risk foods. Here are the 10 most common causes of food poisoning. Number 1. Preparation too far in advance and storage at ambient temperature or in the temperature danger zone, room temperature. Number 2. Inadequate cooling. Number 3. Inadequate reheating. Number 4. Contaminated processed or canned food. Number 5. Undercooking. You must cook to 75. Number 6. Inadequate thawing. Number 7. Cross-contamination. Number 8. Raw food consumed. Number 9. Improper warm holding. And number 10, infected food handlers. Preservation methods remove one or more requirements for bacterial growth. Remember that bacteria require food, moisture, warmth and time. If we can take any one or more of those requirements away, then bacteria won't grow. And this is what preservation does. So let's have a look at the different methods of preservation. High temperature preservation to start off with, pasteurization, UHT or ultra heat treatment, sterilization. Sterilization is used in the canning industry, where the food is heated to 121 degrees Celsius for at least 3 minutes. This is called the botulinum cook. Low temperature food preservation, for example keeping foods in the freezer or fridge. Dehydration is another method of food preservation by the use of drying, salting or brining, or the use of sugar. Drying could be undertaken in hot ovens, or in hot countries could be done in the sunshine. The use of salt or brine, salt being the dry salt and brine being a solution of salt, that's used, for example, when we cure pork to make bacon. Either dry salt, which gives a dry cure, or the liquid salt, which gives the cheap and nasty bacon, which tends to shrink quite a lot when you try to fry it. That's added to the pork, and that draws moisture out of the pork, and it draws it up by a method called osmosis. The use of sugar on food products has a similar effect to salt, but you must use 6 times as much sugar as salt to achieve the same effect. And we use that in preserves. We can use a combination of things like salt and sugar in different foods such as chutneys, pickles and sauces. These are classed as natural preservatives rather than chemical preservatives such as nitrates and nitrites. Pickling is a food preservation process. That's when we use a high acid liquid. Now that could be vinegar or acetic acid or even lemon juice. Acid has a low pH and that will kill bacteria, and certainly bacteria won't grow in a low pH high acid environment. So pickles, chutneys, etc. Another good method of natural food preservation. And the last slide on food preservation, vacuum packing is a method of food preservation where we take out all the oxygen or air from food packaging. Controlled atmospheres, where we use different concentrations of different gases like nitrogen and carbon dioxide. Smoking, using hardwood chips or sawdust such as oak, applewood or beech. Smoking, apart from giving flavour to a food product, actually imparts certain chemicals such as esters, alcohols and aldehydes, and these act as the preservatives. And lastly, we do still use chemical preservatives in food such as salamis and meats and sausages, etc. And these are called nitrates and nitrites.